Here we have a problem where we want a meta disubstituted benzene, and we have a methyl group and a bromine. But there is a little bit of an issue here because methyl is an ortho-para director, bromine is an ortho-para director. So neither of those can direct the new group into its appropriate position. But we do have a way around this, because what we can do is, instead of directly installing the CH3, what we can do is put that on as the acyl group. And the acyl group is a meta director. And then after we do that directing ability, we will reduce it. Okay, so let's do that. I'm going to start with benzene. And instead of methyl chloride for the Friedel-Crafts, I'm going to use this formal chloride, where we have the carbonyl. This carbon here is the carbon that will become the CH3 carbon. We just want a single carbon in that acyl group. And the catalyst, so that actually leaves us with this aldehyde on the ring. But the carbonyl attached to the ring is a meta director. So what we can do now is the bromination. That will direct the Br meta. And then we just need to reduce that aldehyde to the CH3. There's a couple of different conditions you can use for this. We can use the Clemmensen reduction or the Wolff-Kishner reduction. I'll just use Clemmensen, which is zinc amalgam and hydrochloric acid. And that reduces this carbon all the way to the CH3. And that gives us our desired product. In this problem, we want to prepare the tri-substituted benzene from benzene. And we have this ethyl group and the two bromines, and they're all meta to one another. And a common strategy that sometimes people will think might work is to put this ethyl on as an acyl group. But let me show you the problem with that. If you have this acyl group and you try to do a bromination, that will work just fine to add a bromine meta. The issue, though, becomes adding that second bromine in, because this bromine is now our primary directing group, and it's going to direct the next bromine ortho and para to itself. So we can't correctly install the second bromine. So that means we're going to have to use a different strategy. And it may not be readily apparent, but remember that we can put on an NH2, convert it to a diazonium ion, and we can eventually remove it such that it's just a hydrogen. So with that in mind, here's the strategy. We're going to start with benzene, and first put an NH2 group right here. right? That NH2, we're going to use that as kind of our main director and take advantage of it, but eventually remove it. So we're going to put that NH2 on. We're going to convert that to a bulky group. That will allow us to install the ethyl. Then what we're going to do is remove. From there, we can brominate. So eventually we'll get to the stage where we have the ethyl, the NH2, the two bromines, and then ultimately, by the end, we're going to get rid of this. Remove it completely. So that's the strategy for this problem.